A 1-degree difference in Earth's average temperature might seem small, but when we're talking about the average temperature of our entire planet, a 1-degree change makes a big difference. Remember that during the last glacial period, an enormous part of Canada and the United States were covered in more than 2,000 feet of ice. This ice sheet was caused by a cooler climate, and the Earth was only about 7 degrees cooler than it is now. During the last 100 years, Earth's average temperature has increased by about 2 degrees Fahrenheit. That increase in temperature is causing glaciers to shrink, plants to flower sooner, and more frequent droughts and wildfires. Climate scientists have used supercomputers to predict the climate, and over the past 20 years, their models have become more and more accurate. What type of weather the next generation experiences depends on what we do right now, because climate change is linked to the amount of carbon dioxide in our atmosphere. I'm Science Mom.
And I'm Math Dad.
Today we're going to explore the future of our climate, from what changes are most likely to what you can do to help. Hello and welcome. Quick shout out to Malcolm and Emily watching live, to Jill Snelson, Samantha, Olivia. It is good to see you guys here with us this morning. So we are talking about climate change and the future of climate change, which is an interesting, sometimes scary topic.
Super important topic.
Super important topic. And I want to start with talking just a little bit about what a model is. What is a model, Math Dad?
So a model is often used as a prediction where we're trying to, model. I'm using the word model, but we're trying to say what will be happening in the future, what's affecting what, trying to understand the interactions, but usually trying to make predictions based off of information.
Of data. So if we have a graph and we know that right now it's looking like this, can we just draw a line and predict that the next one is gonna be on that same line?
Well, we can certainly make the prediction. We may even be accurate with it. So what Science Mom is saying is often we'll plot the data. We use a graph like this, and we can see, are the values going up or are the values going down? And what we're doing here is there's often a relationship, maybe over time we're seeing things change, or a couple different variables or changeables that we stick in there. And what we're trying to do is look at the long-term trends. So are we going up? Are we going down in what we're measuring? And sometimes it's very clear, sometimes it's not so clear. But that's what a model is.
That is what a model is. And for looking at climate change, there are 3 websites that are the main sources that I used for our information. And I'm going to just put a banner up real quick so that you guys can see what they are. If you want to do more research, one of my favorite is climate.nasa.gov. And if we go to the slides that we got ready, I grabbed a couple images here to show you about what is happening right now with our climate, because scientists have been getting data, and with that data, they can make some predictions. And one is that temperatures are increasing. We talked about this a little bit last time, and CO2 is increasing.
Whoa, slow down here, Science Mom. So this was over time. So started in 1880 here on the graph.
Yes.
And all the way up to 2021 here. I notice that over here, up until about 1940, the average temperature was way lower. And then since then,
it's getting warmer.
Been above that average. And I'm definitely seeing an upward trend.
There definitely is an upward trend. And with the solar radiation, the energy that's coming from the sun, you can see that stayed about the same. So what are the effects? What are we going to predict will happen from the warmer temperatures?
So you're saying that there was a match, though, between the carbon dioxide rise?
Yes.
That almost seems to match, not exactly, but boy, awfully close to this rise in temperature. And we've talked about why that would be, because it's a greenhouse gas, right?
It is a greenhouse gas. So what effects are we going to see? Well, one of the ones that we are most concerned about is the sea level increasing. And we can already tell, and this is just 3.2 millimeters per year is how far it's increasing right now.
So 3.2 millimeters is not very much. So it would take 10 years to go up the length of my thumb. I mean, it's not a big rate of growth, but it's still happening. It's something we can measure.
It still is happening. And we have a quick demonstration to explain why it's happening, Math Dad. So let's go to our big camera view. And first, I want to point out something important to understand. And that's that if you have an iceberg floating in the ocean and the iceberg melts, that doesn't change the level of the ocean. And you can try this out and do a simple experiment just by putting ice into a container of water. This is a time lapse we did. And if you look at the level where the water is, you can see that as the ice melts, the water level doesn't change because most of the ice was underwater. Most of the ice was sunken down.
I know why too. Oh, it's because the mass of the ice doesn't change, regardless of whether it's in a liquid or solid or gaseous state. It's going to have the same mass, so it's putting the same amount of weight down in the water. That means the displacement is already taking place, whether it's ice or water.
That's right. And you just said the word mass a bunch of times, talking about the space that something occupies and how big it is, what its weight is.
The amount of material.
And you know what I just kept thinking?
What's that?
That sounds a lot like mess.
Mass and mess?
Yes.
Whoa.
So if we have icebergs, ice that is not floating in water is an iceberg. If we have ice that is up on land as a glacier, and then it comes into the water, that is very different.
What are you doing?
So Math Dad, hold this up so that they can see really well. And it's nice and flat. This represents the ocean, and this represents all of the ice that is up on Antarctica. And watch what happens to this ocean level as the ice melts and enters the ocean.
Ah.
See, Math Dad, I was thinking of you. I didn't.
No mess. Okay.
But our level went a lot higher. And this is why we're so concerned about the increase in glacier runoff from Antarctica, because Antarctica has miles of ice that is miles thick on it. And it's a huge amount of water that could potentially come down and go into the ocean.
Okay, so you're saying that the ice that's in the ocean, if it melts, it's not really going to change anything.
Mm-hmm.
But ice that's up on land,
when it melts, that changes the sea level a lot. But there is another thing happening with our oceans that actually produces the most increase in sea level rise, and that is just the water warming up.
Wait, so warmer water.
Warmer water takes up more space. And I can prove it to you with a simple little demonstration. This is a flask of water, and right now, right there where my pinky is, you can see a little blue line. That is the level of our ocean. And the ocean in our little flask ocean was in an ice bath where it's nice and cold. But now we're going to put it in a different container, and we're going to put hot water on it.
Okay.
And I want you to watch closely and see what happens when we surround it with hot water instead of cold water.
Seeing the level of the water up in that straw at the top. And you're pouring in hot water. And what you're saying is it will expand.
The water is going to expand because it's getting warmer. And when molecules are warmer, they move around with more energy. And a liquid that is warmer is going to take up a little more space than a liquid that is colder. Now, this takes just a couple of minutes to take effect because the heat has to transfer through from this hot water into the flask. And pretty soon, we're going to see this level rise quite a bit. What's your prediction, Math Dad? Do you think that we can have our sea level rise all the way to the top of the straw, or do you think it will go just part way up?
Oh, the top of the straw is a long ways up. So I don't think we can get that high, but I think we'll be able to see the difference.
Malachi predicts that it might even spit out the top. And Clan Byrne wants to know, can we do this at home? You definitely can. This is just a piece of tubing. A regular straw will work as well. And then I put clay around this container.
You're trying to get a seal?
Yep, you want to make sure it's airtight. Now, I will say this is not going to shoot out the top. It's not a super dramatic experiment, but already you can see an increase.
You can.
Just by getting this water warmer, now our ocean level is quite a bit higher than it was before. It is, Morgan is right, it is going up already.
I thought this was going to take quite a while. So this is true for any substance, whether it's a solid or a liquid or a gas, it'll just take up more space when it gets warmer.
Yes. If you warm something up, it's going to take up a little bit more space. But with water, if we warm water up And the oceans are so big that warming them up even just a few degrees means that the volume increases. Look how much higher it is now.
Okay, I didn't even think it was going to move that much, and it's already gone that high. It may get to the top, Science Mom.
It might get to the top. And it's probably not going to shoot out the top, but it might dribble out the top.
Well, okay, so if our oceans are doing that, this could be a big problem because
a lot of people live right by the ocean.
Yeah, so I'm just thinking about the state of Florida. I know for a fact the state of Florida does not have much rise to it. It's really flat. I think it's all below 100 feet above sea level, like the entire state.
Mm-hmm.
So if the sea level rises, it's going to affect a lot of people there, but also in lots of other places in the world. So a rising sea level is not on anyone's wish list.
No. A lot of people live right next to the ocean. There are a lot of cities, big cities, that would be affected. Not just Florida, but you have lots of cities all over Asia, Africa, and the entire world that'll be affected by rising sea levels.
Oh my goodness.
It got to the top. Malachi was right. It is coming out the top.
Let's put the plate behind it so they can.
Ta-da! We have a rising ocean.
It's going to drip. It's going to do it.
Very slowly. This is like the most exciting but yet slow experiment ever. And
water dripping, all the tension.
Now, the real question is, can we do the reverse? If we stick this back into the ice bath, and there we have a drop on the top. Will the level drop back down again? So we're going to leave this right here, and we'll come back and check on it in several minutes, and it will decrease. So cooling the oceans means the level will drop. Warming the oceans means the level will rise. Pretty amazing, right?
Yeah, that is. Although the consequences are scary.
The consequences are, and when you start researching climate change, a lot of the consequences are definitely something to worry about, and it can be a topic that makes you feel really kind of scared, sad, upset when you research it a lot. But the good news is there are things that you and I can do to make a difference. So we covered sea level rise. Let's talk a little bit more about temperature, and let's turn to the notes. We're on page 50 of the notes. So when we have the planet getting warmer, what is going to happen? Well, there are several different effects that will happen. And let's go back to page 50. We talked about rising sea level, but a warmer ocean is also one that is going to be likely to have more hurricanes, because hurricanes form over warm ocean waters. And the main driving force behind a hurricane is that you have a lot of warmth in the ocean, and that warmth gets transferred up into the atmosphere through that cycle of the hurricane.
So Evie wants to know, is this how thermometers work?
That's a great question. It is a similar to how thermometers work. But thermometers typically don't have water in them as a liquid, but it is exactly how thermometers work.
Oh, that's cool.
Because when the liquid gets warmer, it expands.
Great question, Evie.
Yeah.
All right, so in case anyone is wondering, more hurricanes is bad. We do not want more hurricanes. So this is a negative consequence of the temperatures rising over time.
And we are seeing more tropical cyclones form in general over the last 30 years. We're starting to see an increase in the number of cyclones. Then warmer temperatures has some really big effects on crops. There are certain insects that are killed by winter. When it snows and the temperatures get cold enough, then the insects die, and they then have to migrate north again in the summertime. And if the winters don't get cold enough, there are certain insects like the bark beetle that eats pine trees, the sap inside pine trees, that will become a much bigger problem. But then what about our food and where our food can grow? If the climate changes too much, it might be more difficult for us to grow food. We might have to change the types of crops that we grow. And that is a really big concern.
And certainly the places that we do grow them. And as much as I'd love to be able to grow a banana here, that's not actually going to happen. It's going to be too hot here in Las Vegas.
It all depends. And the extreme temperature events and how acidic the oceans get, a lot of these things, it all depends on how much carbon dioxide we continue putting in the atmosphere. If you look up here, we have a little graph that was taken from the IPCC. And if CO2 doesn't change at all, which is not very likely, not really a possible thing, then the temperature is going to stay about the same. But we have a choice between trying to reduce how much carbon we're putting in the atmosphere or putting out the same rate. And the difference between ending up here or here in the year 2100 is really big.
So 2 degrees Celsius. So that's closer to 4 degrees Fahrenheit. The difference there, man, that is a pretty big change in those curves. And not only that, the trajectories keep going. But by the year 2100, the situation is already pretty dire. And that even in the best case scenario here, where we kind of put the brakes on and we figure out ways to use less carbon, that's still a pretty big rise. Am I interpreting that right?
We are going to see a rise in temperature no matter what over the next 20 years. The real question is, how big of a rise will it be? And can we make it so that 100 years from now, it's not too bad?
Not catastrophic.
Yes, because if we continue on this path, then 100 years from now, we probably won't be living in a planet that's very friendly to human beings and their crops.
Because that's something we've pointed out in weeks past, is that we're in an ice age right now, in the interglacial period of an ice age, but it's kind of the ideal circumstances for us. Prior to this class, I'd always thought of ice ages as, oh no, that would be terrible. We don't like ice ages, but you know what?
We do.
Mammals are pretty good in an ice age.
We do. It's the climate that we're used to. Now, a couple of great questions came in from the chat. One was, could it get warm enough that then the oceans would just evaporate and be gone? And no, the type of warming we're looking at is not going to be warm enough to get rid of the oceans. Thank goodness. But it is warm enough that there will be more evaporation from the oceans, and that will make more clouds. Now, more clouds that's like the wild card of climate change. There's certain things that we can predict pretty well with our models, but an increase in clouds is really difficult to predict because it depends on the shape and the size of the clouds, and they can both warm and cool the planet, and we're not sure which of those is going to be stronger. Now, we live in the desert, and I've really noticed that when it is clear at night and there's not a single cloud in the sky, the temperature drops a lot.
Oh, that's true.
There's a big temperature swing. But if there are clouds in the sky, that's kind of like having a blanket over us, and the temperature doesn't drop as much. It stays warmer at night. But clouds also block radiation. They act kind of like a shield and can bounce radiation from the sun off. So more clouds could make the planet cooler. More clouds could make the planet hotter. It's going to do a combination of the two, and it's hard to predict which is going to be stronger.
So in the chat, Chowie Combo was pointing out that Earth's often seeing these cycles of warmer, colder. So is this just a cycle where we're going warmer? Like, is it really a bad thing, Science Mom, to be experiencing some warming now?
That is a good question. And it all depends on how fast it happens. Earth has had cycles in the past where it has gotten warmer and colder, gone into glacial periods and out of glacial periods. But the change that we're seeing right now is faster than any other climate change that we've seen in Earth's history. And if it changes too much too fast, then we won't have a chance to adapt. So we definitely don't want it to warm up too much too fast. But would there still be life on Earth hundreds of years from now, even if it did? Yes. Like, Earth is definitely going to be okay. There's still going to be oceans. There's still going to be life on Earth millions of years from now. But will humans be around? That depends on what we do now, really, because we don't want to make Earth a place where we can't live. All right, let's take a look real quick at our next slideshow. There are two more effects that I wanted to talk about real quick. So glaciers are definitely melting. There are fewer glaciers. And then we also are seeing less snowfall. That's an effect from climate change that we're seeing right now. But like we said, what's going to happen? If you look at models for predictions of what's going to happen, you will see a lot of variations on a model like this, where we look at low growth versus medium versus high. And it all depends on how much carbon dioxide we keep putting out into the atmosphere. That is the big difference. And now let's go back to the notes real quick, and let's do some predictions ourselves. So we're going to go to page 52 of the notes. And I hope that you guys already had a chance to look at this and read this. If you didn't, you could even pause the video and read and try plotting this out real quick on your own before we go through it. But real quick, just for fun, we'll go through this. So planet Zork and planet Uka are two make-believe planets that we invented for this little exercise. They both have pretty much the same atmosphere, the same ratio of water to Earth, and they both develop these cute little spaceships and airplanes and cities at about the same time, which puts more CO2 into their atmosphere.
So a very similar situation to what we're in now.
Yes, but one of them decides, uh-oh, we need to change.
So-
we need to save these little fry shrimp and reduce our CO2. The other one says, you know what? Change is hard. We're not going to change.
Okay, so the Ukians and the Zorks.
Yep, the Ukians and the Zorks.
Zorkians.
And then your challenge was to see if you could graph these. And Math Dad, should we point out?
A mistake was made. I don't know who could have made this, but don't you worry. The culprit will be caught and punished.
And I just want to state for the record that Math Dad was in charge of these worksheets.
I will not stop until the culprits have come to justice, guys. Don't you worry. Okay. Yeah, the circles. Apparently, the diamonds were supposed to be for Zorks and circles for Uka.
So there's a little mistake there. But if you plot in the numbers, what you will find is that by reducing their CO2, one planet saved themselves from a disaster and one planet did not. Let's go to our slideshow real quick.
Let me show how to plot one of these.
Okay.
So if I look here at this number 206 and 420, what we're seeing is this diamond up here corresponded to that. So that meant we went over to 420 and we went up to about 206. That's where that point came from. And we could do the same thing for the next one. So I see 238 and 430. So 238, I'm guessing it's about, maybe yay high. If I draw a big enough circle, then I know I got it right. But, and then we could connect the dots and we could keep going just like that all the way across. And in fact, if we do,
we come up we see.
And what I noticed is those two lines actually crossed. And yeah, because they crossed, what we're seeing, one of them went high and one of them stayed pretty low. It definitely climbed a bit.
And the way that this results with temperature is pretty dramatic, because with temperature in this planet, if they got up to this level, that was going to be bad news. And the Zorkians definitely did.
Uh-oh. And I assume there's some type of analogy here to Earth.
There is. Well, and the thing with Earth is that we only have one planet. A lot of times with experiments, the best way to do it is to set up two experiments where you change one thing and then you can see what the difference is. Mm-hmm. Well, with Earth, we don't have a planet B.
No, we do not.
And Mars does not count. Nope. Although we could send people to Mars, and that is a really exciting thought about exploring another planet, the atmosphere on Mars is so thin, we could never breathe the air there. And the composition of the atmosphere is really wrong for us too. It's not the right gases. And so life on Mars would be really difficult. And we want to make sure that we get this right. So what can we do? We talked real quick about some of the effects that we have: increasing ocean levels, and we have increasing temperatures, which could affect crops in a real dangerous way. What can we do? There are really just two things we need to do. One is to see if we can take some of the CO2 out of the atmosphere, and the other is to put less CO2 in.
That makes sense. Yeah. The CO2 is the problem, or at least the obvious symptom of this problem. And if we can solve the CO2 dilemma and keep the CO2 levels lower, then all of the global warming trends and things that were coming up earlier will be mitigated or minimized. Right?
We'll be on a much better path. So let's look at two great ideas for taking CO2 out of the atmosphere. One is to plant a forest. Actually, I'm going to show this picture first. So trees absorb CO2.
Yes, they do.
And if we plant more forests, when a forest is young, it takes in, this much CO2. And as it gets bigger, it takes in more and more. And a large growing forest actually does a really good job of removing carbon dioxide from the atmosphere. Now, forest exists on land, but there's also a certain type of forest that exists underwater, a kelp forest. Kelp is not a plant. It's actually a type of algae that's enormous. And there's some exciting research happening right now to plant kelp on these big floating underwater rafts of cellulose. And then once they get big enough, sink them to the bottom of the ocean to take that carbon out of the atmosphere and put it at the bottom of the ocean.
And that would help solve the problem.
The research is in the early phases with that approach, but that approach is not a bad idea. That might help. And then the other thing that we need to do that is just as important is reduce the amount of energy that we use, because the more energy we use, the more carbon we use. And on our notes on page 51, we have a little chart, and I'm curious if you guys had a chance to look at the notes before we started class. Does anyone have a guess for this 32%? Now, this is from data that was taken before COVID, before the big shutdown, and so it might look a little bit different now. But what do you think most of your carbon footprint is? And when we say carbon footprint, we mean if you look at the total carbon dioxide that is produced by something from beginning to end, and you can look at carbon footprint for a single thing like a cup of coffee and what was produced to make that cup of coffee or cup of hot chocolate, or you can look at it for a person.
So the possible answers are these ones down below: transportation, home energy use, food, or consumption. But let's wait for somebody in the chat to weigh in. So what's your guess for this 32% region? That's the question that we're hoping you'll weigh in on. But will you go talk to me about this carbon footprint of this coffee bean?
Yeah, so a carbon footprint is the total amount of carbon dioxide that is produced by something. So for this little example in the notes, we said, how about 1 cup of coffee? And it's not just what you have when you heat up the coffee and cook it, how much carbon that takes, but you also need to think of the farm, when it's milled, when it's roasted, packaged, shipped, the grinding, and the disposal. You know, when you put the coffee grounds into the compost, they're going to decompose to produce CO2.
So that's a pretty big footprint then.
So all of those things combine to create the carbon footprint. And I have to say, in the chat, I think the most common answer that I saw was transportation. It was between transportation and home energy use. Mary says home energy. Alana says, Melinda says transportation. The answer is home energy use.
Aha. Well, transportation was probably number 2, though.
Transportation is number 2. Although with our COVID shutdown, I think we definitely saw a decrease, and there is definitely more home energy use now with everyone being home, and less transportation with people not driving and commuting as much. Oh. So for the average person living in Canada and the United States or other developed countries, most of their carbon footprint actually goes to heating and cooling their home, cooking food, and other, running electronics and things inside the home. And this means that there are specific things that we can do to reduce our energy footprint.
Well, let's ask the chat that. So what are some things we could do to lower our carbon footprint that are specifically in that home energy use category, although the other categories as well? To type it into the chat. What ideas do you have?
What can we do to use less energy at home? I have an idea.
Yes.
When you walk out of a room, you can turn off the light. That's a real simple thing. But if you get in the habit, instead of leaving lights on in the rooms in your house, when you leave a room, turn off the light, that's a way to reduce the amount of energy you're using.
Amelia came up with the same idea. Henry says electric cars.
Electric cars is a great idea. That definitely produces less carbon dioxide than a car that burns gasoline.
Kay says biking.
Biking instead of driving is a great idea. And anytime that we can use our feet or pedal power instead of an automobile, that's going to be less carbon dioxide in the atmosphere.
Kara had the same idea.
Melinda says solar panels, and that's a good idea too. If we can get some of our energy in our home from a solar panel instead of from the electric grid, then we're using less carbon dioxide. We're producing less carbon dioxide. Ooh, Diamond Star says keep the house temperature at 68 degrees Fahrenheit. And it's true, if you keep your house a little warmer in the summer, a little colder in the winter, then that helps to reduce and save energy as well. Very nice.
So just walking when you don't need to drive somewhere, Spaska.
Yep.
Melinda, same idea.
I'm seeing some great ideas in the chat, you guys. This is wonderful.
Amy says, don't waste the water. Water your plants with it.
That's a good idea too.
It's a really good one in the desert where we live.
Now, having these simple ideas at home, it might seem like, well, this is just me at home. It's not making a big difference. But if it becomes the common thing where most people make these changes, that will indeed make a very big difference. But it's also important for us to try to make sure that there are changes that happen nationally. And one simple example is that recently there was a bill passed in the UK that said that appliances at home, like dishwashers and washing machines, they have to be durable. That means they have to last at least 10 years and they need to be repaired, because certain companies had figured out that they would make more money if they built washing machines that would only last about 5 years and then they would break down. And then when they would break down, they didn't sell parts to replace them. So then you'd have to buy a whole entire new washing machine.
Oh, that makes me mad.
That makes me mad too.
Yeah, so wasteful. Because think about all the metal and the parts that go into a washing machine.
It is.
And they're very expensive, and so that's just wasteful as can be.
So if we find out that certain companies are doing things like that, they call it, I think it's intentional. What is it, Matt?
Obsolescence?
Yeah, intentional obsolescence, where they intentionally build things that are going to break sooner so that then you'll have to buy more. That's not good for the environment. We've got to say something and say, no, let's do things that are good for the earth.
I love that the suggestions have kept coming in. People are thinking, all right, what can I do to be less wasteful, to reduce our carbon footprint? And yeah, you guys have some great ideas. I love seeing the recycling suggestions. Even composting, and just not wasting food. Stop wasting things. It bothers me to no end when you buy something and it comes with tons of plastic, because where did that plastic come from?
Gasoline, really.
Yeah.
The plastic is produced by petroleum and natural gas, and the products that go in to make it are from fossil fuels, and then the process to make it is fossil fuels as well. Let's check on our ocean real quick, and then we are going to have our mystery, Where in the World mystery. So our level is not quite down to as low as it was when we started, because our ice cubes are mostly melted in here, but it definitely dropped. It's a lot lower now than it was before.
Uh-huh.
And if we put it back into hot water, would it rise back up?
It would.
It definitely would.
Yeah,
you can just keep going
up
and down by changing the temperature. And real quick, there was a great question from Kate. What happens to the molecules in cold water versus warm? Why does this happen? And it's because of how the molecules move. So molecules in a liquid, they're tumbling around each other and they're moving. And when you increase the temperature, they move faster and they're a little bit farther apart. So the water didn't change. It's still water, whether it's cold or whether it's warm. But how the water molecule moved, that's what changed. And when it's warmer, they're a little bit farther apart and take up just a little bit more space.
Yeah, and it really is just a tiny change. By using that straw, we're kind of magnifying the difference, making it much more visible. But when you think about the oceans, how big they are, just a tiny change is going to, be pretty noticeable on our
end. Make a big difference. Yeah. Are you ready for your Where in the World mystery, Math Dad?
Today's the day I'm going to get it. Actually, I think I got the last two, didn't I?
You did get the last one.
Yeah.
So famous cities are a little easier than ancient ruins.
Right.
So this old fishing village, it used to be an old fishing village, was a thriving pearl diving industry, but now it's home to the Burj Khalifa, the world's tallest building. What city is this?
Okay, I think I know this. I do think I know this, but I'll let the chat think for just a moment. But this has got to be Dubai.
That's right. It is Dubai. Dubai is a fairly large city.
Arab Emirates.
Yep, in the UAE, and it's a city of only about 3 million, which is
only 3 million.
Small compared to Shanghai and Tokyo, the cities that we had the last two times, but still a very large city. And it is famous for its enormous buildings. And right there in the center, you can see the Burj Khalifa. It is so much taller than the other skyscrapers.
It's like two of them stacked on top of each other.
It's kind of amazing. It is enormous.
Yeah. So an engineering feat. I mean, amazing by any standard.
Yep, definitely. And now it is time for us to pull up our polls. So that means I get to hold the sleepy puppy.
Okay.
And go to sciencemom.com/
itempool.com/sciencemom/live.
Thank you, Math Dad. itempool.com/sciencemom/live. And while Math Dad is getting the polls up, I want to wish a very happy birthday to Bree, who turns 10 today. Happy birthday, Bree. And to Simon, who turned 9 yesterday. We hope you had a wonderful birthday, Simon.
All right, we're going live with our polls.
The first one is a throwback to yesterday's topic. A drought will cause growth rings in a tree to be thinner, thicker, or the same. What
Ooh.
is the answer?
See, it's easier to get the right answer on the day of because we just barely talked about it. But can you remember what we talked about
On the next day.
Yeah. Well,
And
I'm seeing most people are voting for one category.
And I did see a couple people in the chat saying, what does USK stand for? It's Undefeatable Science Kids, and that's who I'm rooting for.
Oh, wait a minute. You're cheering against me, Science Mom?
You're cheering for them too, you just don't know it.
Whatever, they're going down. They are going down. And the answer was thinner. So if there's a drought, the rings will be thinner. That's accurate. That is true. And why would that be true?
Because the tree is not growing as much during a drought. It has to conserve its resources, and it's not putting as many cells in that new layer.
Oh, nicely done. Question number 2. A carbon footprint is which of the following? So is it a footprint made of charcoal? Is it the trail left after harvesting diamonds? Or is it the total amount of carbon dioxide produced by a product or person? Or is it the amount of carbon in an item?
Which of these is correct? And Remington Wolf asked a great question. Could the bottle break from warming the water? Because this bottle I'm using, you could do it with a glass or a plastic bottle, but if you're using glass, make sure that it's completely full of water. If it's completely full of water and I put it into a pot or a container that has really hot water in it, it won't break. But if the glass is empty, then you need to be really careful. If you have a hot glass and you put ice in it, or if you have a cold glass and you put boiling water into it, you need to make sure that you do that slowly and carefully, because if it's empty and you change the temperature all of a sudden, the glass can break.
I think we should share an embarrassing story after this.
I don't think we should.
No, it's too late. I mentioned it. All right. So the correct answer was C. The total amount of carbon dioxide produced by a product or a person is what we call our carbon footprint. You guys crushed that one.
Yes, they did.
Nicely done. All right.
And are we doing the embarrassing story now?
Yeah, here's the embarrassing story. We needed...
So I was making bread, and I wanted to make like artisan level French bread with like the really thick crust. And to do that, you have to have steam in the oven. So I had a metal pan in the oven, and I would like dump in a little cup of water onto the metal pan, and it would produce steam and get the oven nice and humid. And not really thinking ahead, I tried it one time with a glass pan.
I mean, even though we got boiling water to put in there, so it was all ready to steam.
So the water was 212 degrees Fahrenheit, but my oven was like 400 degrees.
Uh-oh, that's a temperature difference.
And so when I poured the boiling
hot water
onto the glass pan, the glass pan totally shattered in the oven, and I felt really embarrassed that I had made that error.
No.
Okay, embarrassing story over.
Moving on. All right. Increased average global temperature will result in which of the following? So select all that apply: more hurricanes, rising sea levels, more heat waves and droughts, and changes in ocean currents. What will be the result of increased average global temperatures?
Alondra asks a great question. Is it called climate change, global warming, or a global climate crisis? So when you and I were kids, this was when people talked about rising CO2 and the earth warming, they called it global warming. But climate change is a better name because it's not just a global warming that's happening. There are a lot of changes to weather patterns, and it really is climates that are changing.
And it's important because with the difference between climate and weather, it's coming into play here. Remember, climate was the average
over
of the weather
30
over
years.
30 years. And so then it's a long-term trend. If you talk about global warming, then people can say, look, it's cold outside. See? Global warming is not real. But if you talk about climate change and these long-term trends, then we're all using the same terms, meaning the same things, and it's a much better way of describing it. So climate change, I think, is a great one. And then
climate crisis. We are experiencing. We'll talk about that after this question. But let's do this question so we're not covered by green bars.
Oh, you're right. They were all true. They were all going to happen. The only one that didn't get selected as many was changes in ocean currents, and I guess we didn't talk about that much.
We're going to be talking about that more when we come to our hydrology section. So we'll talk about that more then. But climate crisis is an appropriate term, especially if our current trajectory continues, because we are seeing really dramatic change, and if it continues at this pace, then it could be really catastrophic.
Yeah. So in the developed country, the majority of a person's carbon footprint comes from which of the following? Transportation, home energy use, food, or consumption?
And by consumption, we mean just the things purchased, the things you buy. So if you buy a washing machine, what energy and what carbon dioxide was used or was produced to make that washing machine?
So we talked about solving this terrible problem of the ozone layer being depleted. And this really was a problem that was going to affect the entire world, and the consequences are going to be disastrous. Yet all the nations kind of came together, and we are well on our way to solving that problem. Our trajectory looks good.
It does. The story of the ozone hole is really encouraging because we are making progress to fixing it. Climate change is a more complicated problem because it has to do with our energy use, and reducing energy use is something that affects our quality of life.
All right. So the correct answer was home energy use.
They knocked it out of the park.
Nicely
Are you getting
done.
nervous, Math Dad?
No, I'll get him with this one because it's going to stump them big time. All right. So select all of the following that apply. Which would be the most effective in reducing CO2 emissions?
But if they're supposed to select the most effective, then that's not select all of them.
You're saying I wrote a bad question, Science Mom?
He kind of.
Everyone's a critic. All right.
Which would be most effective in reducing carbon dioxide emissions? To use renewable energy sources instead of fossil fuels, to reduce the amount of energy used, to purchase more cars and build bigger houses, or to burn natural gas instead of coal. So if you were going to pick one of these to do, which one would reduce CO2 emissions the most?
So you're saying there should just be one correct answer?
Yes,
Okay,
that's what I'm saying.
I get where you're going with this, Science Mom. I see what you're saying. I see what you're saying. This is good. But yeah, so seeing the world come together to solve the ozone layer problem is awesome. And to think about the climate crisis, this crisis that we really would want to avert through exceedingly big climate change. I mean, I really hope that we can take some steps and reduce the global carbon footprint.
Me too.
All right. And they said use renewable energy sources instead of fossil fuels and reduce the amount of energy used.
And I'm really happy that B was the number one choice, because reducing the amount of energy used is even more effective than, I mean, if we could just all of a sudden not use any energy, that would reduce carbon dioxide dramatically. Using renewable sources instead of fossil fuels is also a good change, but it takes fossil fuel energy to actually build the renewable energy sources. To create a solar panel or to create a windmill, you have to use fossil fuel energy to create it. So reducing energy is one of the best approaches.
You're saying I got my own question wrong?
I'm saying they deserve a victory dance, Math Dad. That's what I'm saying.
Oh, man. All right. Time for a victory dance. Here goes.
Science puzzle dance with you.
Oh, sorry.
Kaladin was looking at you the whole time like, what is he doing? That is really strange. And I see Wayfaring Scholars requested a video. We did film a couple of silly videos of Math Dad doing dances. We'll try and have one of those ready for Friday. Speaking of Friday, on Friday, we are talking about problem solving and the scientific method. And you will want to have some spaghetti or any other type of pasta ready, because we are going to have fun designing some bridges and then testing them to see how much weight they can hold.
Am I going to win? Yes, I'm going to win.
That's what he thinks. But I think the science kids are undefeatable. So.
Oh, I figured I'd just compete against you, though, because they can't show me their bridges. I mean, they might stand a chance, but you don't.
And Patrick asked a really great question, and we will finish on this question. Patrick asked, how many degrees warmer is the planet getting each year, or is the planet going to be each year? And the answer is that it really depends. Right now, we're seeing the most rapid warming at the poles, actually. So the climate is changing the most up in Alaska and the polar regions and down in Antarctica. But as time goes on, those patterns can change. But we're hoping if we can keep our warming less than 2 degrees going forward, that would really help a lot. We don't want to go more than 2 degrees on average. Now, when the average temperature increases 2 degrees on average, That doesn't mean that your temperature that you experience in the summertime is only going to be 2 degrees more. It might be 10 or more. Dry or wet pasta? Dry. Dry pasta.
Definitely dry. We're going to try to build bridges with it.
Uncooked pasta.
Yep. Yeah, that's right. Uncooked, not just dry.
Uncooked. Yeah, don't cook the pasta. We thank you guys for joining us. We hope that you enjoyed this lesson, and I hope that you will make use of some of the good resources that we mentioned at the beginning, climate.nasa.gov and other websites where you can learn more about climate change.
And that you look for ways to reduce your own carbon footprints and your families. We've got to change the trajectory we're on.
Definitely. Work hard, grow smart, and we'll see you on Friday.